This lesson is on congruent polygons. So consider the following. Which of the following pairs of shapes are congruent? Give a reason why or why not. Write this reason on your paper. By definition, for two or more polygons to be considered congruent, all of their corresponding parts must be congruent. When writing congruent statements, order matters. This will be the theme of today's lesson. Let's practice writing congruent statements. Write all of the segment and angle congruent statements for each pair of polygons. Then write the congruent statement for each polygon. So let's start with our segment congruent statements. If I look at my diagram, I can see that BC and EF are congruent because they're marked that way with the little hash mark. So we'll write that down. BC is congruent to EF. Another congruent segment, AB and DE. Both of those have the two hash marks. We'll add that to our list of congruent segments. The last set of congruent segments would be AC congruent to DF. Again, that's noted in the diagram with the three hash marks on each segment. Now let's move to our angles. Angles, remember, are marked congruent by the arcs. So I see that B and E, those angles each have one mark. So I could write angle B is congruent to angle E. Angle C is congruent to an angle. On angle C, we notice there are two arcs. So if I go to my triangle on the right, I see that angle F also has the two marks. So C would be congruent to angle F. Finally, our last congruent angle pairing would be A and angle D. They each have the three arcs. If I want to write a congruent statement, pick one polygon, in this case a triangle, to go with first. I'm going to start with the triangle on the left. I'm going to name him triangle A, B, C. The first polygon does not matter as long as you follow the vertices or the corners in one continuous motion. Don't bounce through the polygon, just follow it around as if you were drawing it without picking up your pencil. It's the second polygon after the congruent sign that's going to make a difference. So this is still a triangle, so I'm going to put a triangle symbol in front. We want to make sure that the vertices and the segments line up. So on my first triangle, I wrote the vertex A first. So A is congruent to angle D. So D needs to be the first one we write. The next letter in my congruent statement for my ABC triangle is the letter B. Over on our congruent angles, we see that B is congruent to E. So E would be the next one. Then I'm going to verify that F is the last one and I didn't miss it somewhere. So I see in my list of angles over there that F is congruent to C. So now that would be a proper congruent statement. You could also write these in different orders. Let's say I wanted to write it as triangle B, A, C. I didn't actually change the triangle, I just changed the order. So I need to make sure the order on my other triangle matches. Remember, angle B is congruent to angle E. So now we'll start with angle E. Then we have angle A, who's congruent to angle D, and F is congruent to C. Those represent the same polygons and the same information, but they look a little bit different, a different order. This is an important thing to notice. You may write your congruent statements differently than I may or your friend or somebody else may, but you could still be talking about the exact same information. We're going to see some of that later and how that works. Why don't you take a moment, hit pause, and try writing out your segment and angle congruent statements first. Okay, so you've tried it. Let's go through. Segments. I'm going to start with the polygon on the top and then do the ones on the bottom. So on the top, my first segment I see is TU. So segment TU, he has 3 congruent marks. The segment on the bottom with 3 congruent marks I see is segment DC. So TU is congruent to CD. I'm then going to go back to my top polygon. I see ST is marked with 2 congruent markings. So segment ST is congruent. While on the bottom one, the 2 congruent marks are on the segment BC. So those must be congruent. The last segment that has a congruent marking is SR. So SR would be congruent to the segment with 1 mark, AB on the bottom. You'll notice on the top polygon, UR is not marked congruent, but he is congruent to another segment. He's going to be congruent to AD because both of those segments are marked as having a length of 2.5. Remember that if 2 things have the same measure, that means they are congruent. And we're going to see that with the angles here. Notice that the angles aren't actually marked congruent, but they all have angle measures. So angle T, he's marked as having a measure of 104. The bottom polygon, angle C, also is 104 degrees. So T and C would be congruent. Angle U has a measure of 65, and on the bottom polygon, 65 degrees is angle D. So angle U is congruent to angle D. 63 degrees describes angle S on the top shape, and it also describes angle B on the bottom. Then finally, we have 128 degrees. Angle R is congruent to angle A. How did you do? Were you able to get all of those? If so, you're doing great then. Let's write our congruent statement now. Remember, just pick one polygon to start with. I'm going to start on the top. T, U, R, S. And there's no method to it where to begin. Just pick a spot and start going around the polygon in either direction. Is congruent. This is the part that matters because order matters. Angle T is the first one on my top polygon, so it needs to be the first one I list on the bottom polygon. T is congruent to C, and then go down the line. U is congruent to D, R is congruent to A, and S is congruent to B. So that would be one congruent statement that I could write. Now, let's look at doing this the other way. Here's a congruent statement. Label the diagrams. The first thing I'm going to have to do is label some vertices on my first triangle. So I'm going to start with the triangle on the left and call it GHK. Since I don't know anything about the angle measures or their relationships, I can label it in any way. So I'm going to just start this way with G on the left, H, and then K on the bottom. So now I need to label these to make sense. Well, I see that K seems to be pretty easy to pick out on this triangle, so I'm going to start with that angle. In my congruent statement, I see K is the third one, so on the other side I also see W is the third angle. So W must be congruent to K. So I'm going to label W in the spot that seems to correspond with K, but more importantly, I'm going to mark them congruent. Arc and arc. Another angle that seems to be pretty simple to pick out is this one H. He's all the way drawn out on the side. So I'm going to look at my congruent statement. I see that H is the middle letter. On the other side of my congruent statement, I also see R as the middle letter. These angles must be congruent. R is going to be in the one corresponding to it. Remember to mark them congruent. We've already used one arc, so now we need to use two arcs. This last angle must be T. And I will verify by looking at my congruent statement. T is the first one on the right of my congruent statement. I also see that it's G. In my diagram, those seem to be corresponding parts. Label them corresponding. 3 arcs this time. There. But don't forget to label your segments. For polygons to be congruent, all of their angles and all of their segments or sides must be congruent. So in my congruent statement, GH, I'm going to put 1 tick mark there, and on the other side of the congruent statement, it's TR, 1 tick there. HK is the next part of that congruent statement, the second and third letters of it. So HK is going to be congruent to the second and third letters of the other side of my congruent statement, RW. Make sure you mark those congruent. And finally, I have TW and GK. Always verify and don't make the assumption. Well, GK is the first and the last of my congruent statement. TW is also the first and the last. It's okay that they aren't next to each other. So these triangles were pretty close to the same orientation. Let's try one that's a little bit more difficult. NBRP is congruent to ASDK. These vertices are already labeled for us, so we just need to mark the angles and the segments. Why don't you hit pause and give it a shot yourself? Make sure you pay attention to order. Go ahead, hit pause and try it. Alright, let's see how this works. Angle N is the first one on the left. So I'm going to mark him with 1 congruent mark. And the first one on the right is A. So he must be congruent to A. Keep going in order. My next angle is B. Give him 2 arcs. And I see he's in the same spot of the congruent statement as angle S, the second position. Next up would be R. 3 arcs for him. And then D is in the same spot, third or second to last. He'll also get 3 arcs. Finally, the last angle, P. 1, 2, 3, 4. And he's congruent to K. 1, 2, 3, 4. Don't forget your segments though. So on the left, NB. And on the right, the first 2, AS. Those would be my congruent segments. Keep going down by pairs. So now we're at BR. he's going to be congruent to the middle two of the second polygon, SD. On to the next pairing, RP, the last two positions, he's going to be congruent to the last two positions of the second polygon, DK. And finally, we have the start and the end letters. NP will be congruent to KA. Alright, so that's for our diagrams now. Let's move into some problems without diagrams. Can you do it with just a statement? Here's how this works. The first one says angle W is congruent to whom? Well, I see angle W is in the second polygon, and it's in the second position. So in the first polygon, I need to find the vertex that's in the second position. I see that's J, so angle W must be congruent to angle J. Next angle we have is H. Well, H is in the first polygon, and he's in the first position. So he must be congruent to the first position of the second polygon. That would be Q. So angle H is congruent to angle Q. Let's try segments. Segment TY. I notice that TY is part of the second polygon, the last two positions. So those are going to be congruent to the last two positions of the first polygon, LP. So segment TY is congruent to segment LP. Try PH. Who is PH going to be congruent to? Well, PH are the last and the first vertices of the polygon. So they're going to be congruent to the last and first of the second polygon, YQ. Okay, so now here's a little challenge for you. Test yourselves. Can you finish this congruent statement? It's talking about the same polygon, but it put the vertices in a different order. So now we're going to start with the vertex K. Use your original congruent statement to help you out. So K is in the middle of the first one, so the middle letter of my second one is R. So now I'm going to start with R. L is the next vertex. Keep going down the line, so L is the second to last. That means T would be next. Continue matching the letters. P matches with Y. H matches with Q. And finally, J matches with W. So this would be another way to write that congruent statement. They're talking about the same polygons, but they look a little bit different. Why don't you guys give this one a try first? Alright, welcome back. Here's the answers. How did you do? Are you getting good at matching the spots? More importantly, are you understanding why the order matters? Okay, now let's go ahead and see how this applies to some of our other types of problems we'll see in this unit. But first, let's remind ourselves. Congruence means equal in measure. We're about to move into some algebra skills. So in geometry, we say congruent. In algebra, we say equals. So find the indicated value using the information given. So here we're given a congruent statement. Triangle GIH is congruent to triangle BCM. So the first question is, find the measure of BC. So the length of BC, if I look at my congruent statement, BC are the first and second letters in that second polygon. So he's going to be congruent to the first and second letters of my first triangle, GI. Well, let's look at the diagram. GI, it says he has a length of 2.9. BC then must also be 2.9. Now we need to solve for x. Well, x is in my second polygon, BCM. And I see that he is on the segment BC, representing that BC is 2x minus 3. So I know BC is 2x minus 3, but in our congruent statement, we also said BC is 2.9. Well, now I can just set them equal. 2.9 equals 2x minus 3, a simple substitution. Let's go ahead and solve. Add 3 to both sides. So 5.9 equals 2x, and then I want to divide by 2 to solve for x. So x equals 2.95. Of course, we could always check our answer if we plug in the x value and making sure that we end up at the 2.9 we originally started at. So BC is 2x minus 3. So 2 times 2.95 minus 3 is 5.9 minus 3. That subtraction would give me 2.9, which confirms that BC is 2.9. We did our algebra right. Congrats! Let's go to another problem. This problem's a little bit different. We have our congruent statement. QRS is congruent to BCA. It's not all marked on my diagram though, so we're going to have to fill in some blanks first. Well, when I look at this problem, the first thing I notice is that triangle ABC has 2 of my 3 angle measures there. That means I could find the third one using triangle sum theorem. So I'm going to do that. 45 plus 80 plus C equals 180. Adding up all 3 of my angles. 45 and 180 is 125. And then I'm going to subtract 125 from 180. And I find the measure of angle C is 55 degrees. So I'm going to label that right up here, 55. I'll change my color of pen so we don't get confused in the work to keep it sorted out. Now I can solve for x. I see x here is in the angle R. So I see that the angle R is the second position on my first triangle. The second position on my second triangle is C. So R must be congruent to C. Angle R is congruent to angle C. Let's substitute in their values. 5x equals 55. Well, now this looks pretty simple to solve for x. Just divide by 5. We see that x equals 11 degrees. Let's write that down. So I hope you guys are doing well with this. This next problem is a little bit more complex. They give us a lot of information and a lot of things we need to solve for. So we need to take this one piece at a time. Angle S is the first part here. Look at your congruent statement. S is the very first vertex on the right side. So he's congruent to the first vertex on the left side, angle D. If I look at the diagrams, I see that angle D is 102 degrees. So angle S must also be 102 degrees. Our next question is, find the length of SP. SP are the first and the second positions on the right side of my polygon. So they are going to be congruent to the first and second positions on my polygon on the left, DE. We're looking for DE on my polygon. In the diagram, I notice DE is 8 feet. so SP will also be 8 feet. Now we need to solve for x. I see that x is in 2 spots of my diagram. So let's write both of those down and see if we can work with something. Angle Q equals 6y plus x. And segment QR equals 2x minus 4. Angle Q has x and y, but I notice QR only has x. So let's work with that segment. To finish this out, we need another value. Q are the third and fourth positions of my right side polygon. So they're going to be congruent to F and G because that's in the same position. FG in this diagram I see is 12 feet. So QR is congruent to FG, and FG equals 12. Well, that means that QR is also 12 feet. Substitute those in and set them equal. QR is 12 feet, but QR is also the expression 2x minus 4. Let's solve. Add 4 to each side. 16 equals 2x, and divide by 2. X equals 8. So x is 8. Now we can move on to y. Remember that angle Q? Angle Q is where we found the variable y, but we also had a variable of x. We just solved for x, so let's plug the x value in and see what that gives us. Angle Q equals 6y plus, instead of x, let's write 8, because we solved to find that x equals 8. Well, that looks friendlier. Now we only have one variable. But I still need to find out what the measure of angle Q is so I can solve for y. Angle Q is in the third position of the polygon on the right, which means he's congruent to the third position of the polygon on the left, angle F. In the diagram, we see that angle F is 68 degrees. Well, that means angle Q must also be 68 degrees. So angle Q equals 68 degrees. Substitute that in and set them equal. 68 equals 6y plus 8. Solve for y. Subtract 8. 60 equals 6y. And finally, divide by 6. So we see y equals 10. Alright, so that was our last example. Let's just summarize this up a bit. The key thing to remember, order matters. And that's the end.